So my project here is to make a little box to hold all my end mills. It's a pretty simple box. I've basically used a tab and slot construction for this. So all little pieces of plastic, either acrylic or polygon. I'm not really sure which one it is, but it doesn't really matter. They should cut about the same anyway. Acrylic might be a little bit stiffer, if anything. You can see it's not exactly a correct CAD model, but it's okay. It's plastic. It'll make itself work. I can always file down a corner if not, if I need to. This is really just a quick and dirty thing I made in about half an hour to just work. Hardest part about this is probably the dog bones here. If anybody has a good way of making these, I'd really appreciate it. What a dog bone is kind of like a thing that lets the end mill come in. So if I have like an end mill, right? Like say this is my end mill here. Out there. The end mill's got to come into the slot, and obviously if I just go along this rectangular slot and just come around this way, well, the rectangle's not going to fit in there because it's going to leave material right in this corner over here. So a dog bone is basically just a way to ensure that this thing kind of goes and then comes in like this, rolls around, and then comes out, and then comes over here, which basically ensures that a corner can fit in here. And I've got, I think, a 1,000th of an inch clearance. So yeah, 1,000th of an inch clearance there to guarantee that a rectangle slot or rectangle tab will fit into there. And these are pretty time consuming to make. Like, they're not that time consuming, you know, a few minutes or something. If anybody has like a macro or something they know to make this a bit easier, I would appreciate it. So if you can let me know about that, that'd be good. But yeah, I put dog bones on all this stuff. You know, I got tabs, pretty straightforward. And then I put it all into an assembly. And actually, I should talk about this. But you'll see I have a whole bunch of pressed things. That's because the way I did this, for each one of these, I would have a separate body deletion here. So if I roll this back here, basically I would construct this as a separate body part with without the tabs cut out yet, right? And then I would do a removal. So I would remove everything that the base is touching, which basically cuts out exactly the correct length tabs, because it'll cut out all the parts that the base, you know, is touching this thing in. So it'll make exactly the correct size tab, and it's a pretty good way to do it. You know, this is the first time doing it this way, so that's why it's a little bit messy on the left panel here. But in the future, I'll know how to do it pretty accurately. Anyway, and these pockets are all sized to hold end mill holders. So this is like, I think, a 3-inch, yeah, 2.82 by about ½ an inch square. So I figure I'll put my 4mm Huhan end mills in this big pocket, and then you know, the other end mills in these smaller pockets here. And yeah, that should work out pretty well. This guy is not the correct part. This should not be Longwall 4. It should be a different one. But I don't know which one. I think I screwed up the CAD a little bit, which is why it looks like this. But it's supposed to be this pocket's open, so I'll probably have to cut this off later. That's okay. I don't really want to change this right now. And then after that, I put them all into a new assembly, all the parts that I want to cut out, made them all flat. And, you know, it wasn't really too careful about that, but basically I just made them all coincident to the top plane there. And then I saved this as a step file. And then I opened the step file in Fusion, and I've got 2 operations set up here, a drill operation and a cutout operation. The drill operation's just for drilling holes and doing these little pockets here. So that way I can do this operation, screw them down, just as one complete separate program. Then I have a separate program that just does the cutout. So on the cutout, I've got 2-pass contour with a finishing pass right there. Pretty straightforward stuff. But let me just go in detail a little bit about these. So for the setup, I have it set up as, you know, select ZX plane x-axis because, you know, it's gets kind of funky when you import to Fusion. I've got points it down here so I can zero it down to the wasteboard, and that way I'm pretty much guaranteed to cut through. Whereas if I have, like, because my stock thickness is somewhat unknown here, so I'm being safe by just having it down here instead. In case like the plastic bows or something, I don't want to have to zero on bowed plastic. Relative size box, notice no stock. Width and depth are there. They're the correct size for me, you know, to actually stay inside my material there. Height is 0.2. Sure, that's defined by the CAD. And now for my bore mill, so this is interesting. So if you're doing drilling in Fusion, right, or you're helical interpolating a hole with an end mill, right, like going down to helix to cut it out, you have 2 options. One is to use the 2D bore tool, and the 2D bore tool is kind of cool. Like, it gives you a lot of options here. You know, finishing passes, multiple passes, that kind of thing, right? But as the downside, if you want to select stuff, you have to select each hole individually. So if you're doing a lot of holes, this just isn't worth it. It just takes way too long. So to save time, if you do drill operation, And I have, you know, my 1/8 inch flat end mill selected there. Right over here somewhere. I have no idea where I put this thing, actually. No, it's not important. The point is, you have your end mill selected, right? And you want to drill these holes, and these are like 0.196. You have 0.2 right there. Then what you do is you can actually just select one hole, and this is selected this one, and just do select same diameter, and it'll just select every single hole in the job with the same diameter, which in this case happens to be all of them, because they're just made for screwing stuff down. And what you can do is you can say select bore milling. So bore milling will just do a straight helical interpolation. So if your hole is like really big, then you'll want to use a pocket for it anyway. But if your hole's like a small hole, then this will work just fine. And you have to set the diameter manually. Keep that in mind. So you can't just select like every single hole in your job and just say helical interpolate. You have to actually set the diameter, and it'll just do that diameter. So you need a separate one of these for each diameter. You get your pitch there. You can do multiple steps if you want to, you know, go down like in a little bit each time. Or, you know, in this case, step over. So actually, you go out to the sides this way. And repeat pass if you want to have it do basically like a spring pass. I didn't find a need to do that, but, you know, probably fine. In my case, this is very, very convenient if you want to do multiple holes. Contour's pretty straightforward. I just, you know, select my contours there. For my heights, you know, I have it go through all the way by 60 thousandths. I don't want to make the same mistake I did last time, where I don't go through all the way. Step over 3 thousandths for my finishing pass there. It's 2 finishing passes is kind of like an air quotes thing. It'll actually just generate 1 finishing pass. It's just that like the bottom pass is counted as a finishing pass. And I've got a 4-degree ramp right there with the 0.1 inch clearance. So it starts 0.1 inch above the part and then ramps down at a 4-degree angle. I've got lead in and lead out enabled. You don't really need them for this. I really shouldn't have enabled those, but it's probably fine. I don't want to have to repost it. I already posted this, so I don't want to repost it. Feed rate, pretty straightforward. I've got 72 inches a minute at 18k RPM, 4,000 feet per tooth, with ramp, lead in and lead out at 54, and a plunger at 24. Pretty standard feed rates. I was recommended this by someone on the Discord whose name escapes me. It wasn't Juju Beans, it was someone else. But yeah, pretty solid feeds, I think. The other day I was running at about 20 or 40 IPM, which was definitely too slow. You could hear it, you could see it melting, honestly. The cutting feed rate, 72 IPM, I think I'll get a much better result out of. For the cutout contour, I'm doing 72 IPM for the pass there at a 1/8 inch depth of cut per pass there. So I've got multiple depths. Finish only at final depth to make sure that I actually only do finishing pass with final depth. And that's a very simple 1/1000th of an inch step over for my finishing pass. Yeah, there's that. Oh, one more thing. For this guy, I've got the heights up through to breakthrough of 0.06. And there was one more thing. Yeah, and I got 54 IPM for the cutting for the bore. The thing about the boring operation is that it uses the regular cutting feed rate for the bore instead of the ramp feed rate, which doesn't really make sense to me. It should be using the ramp, but yeah, Fusion's weird like that. And let's simulate this real quick. Alright, you can see it doing that nice little helical interpolation right there. And there's my step down of 0.03. For a bigger hole, you can probably do a larger step down because it's a smaller ramp angle. But for these small holes, I want to do a small step down to make sure my ramp angle is not too aggressive and not just plunging in. Yeah, there you go. And let's see if I can get the dog bones in there. Oops. Yeah, there you go, they're the dog bones. You can see it goes down to that ramp, goes down to the bottom, opens up the dog bones, and it's done. Pretty straightforward there. Cutout operation, again, 2 passes to get to the final depth, and then 1 finishing pass, so 3 passes total for the 0.2 inch material thickness. Should be pretty quick. And overall, this is going to take 17:55. So let's go over to the router and cut this out. Oh, and one more thing. For my post, I've got a special Weihong post there, and that is something I found on a forum. It seems to work pretty well. So there's that. And generally, I'll name these like Op2 and Op1, like Op1 for the drilling operation, Op2 for cutout. All right, now let's go over to the CNC router and do this. Well, we're milling plastic right now, and we're going at about, I want to say 72 inches a minute, 18k RPM. I think I'm actually going 54 inches a minute on those slots there because I'm ramping down, and during the ramp I want to go a little bit slower. But yeah, it's sounding pretty good. I I can hear it getting a little bit loud right before it finishes the each contour, but it's doing pretty good. Oh, there you go. Looks like it's finished the job. So, basically, what this setup here is, and let me take this carabiner off real quick. That's my setup for turning on and off my air. But you can see this bit, just a little hoo-how, 3.175mm, still feels super sharp, cold to the touch, did a great job. And I don't know if you can tell here, but these slots also look really good. You can see they're like, a little foggy as, you always get the cuts like that. But otherwise, beautiful. Just beautiful cuts right there. And one thing I wanted to test here is to see if this guy will fit in this slot, which is really what these slots are made for. And they do, and it's a nice tight fit, just like I wanted. I set these to be 5mm wide, because this is about 5mm thick here. Maybe a little bit thinner. And it's a nice, tight slip fit right in there. Not even tight, actually. Maybe a little bit too loose. But these are, I think, nominally 3/16 or 0.19. So it makes sense. I mean, it's plastic. Plastic's not always perfect when it comes to the tolerance. But pretty good overall. So that was the first operation. I'm just cutting everything out. Next, I'll screw everything down. And I'll be back for doing a cutout operation. And we're back. Running 72 inches a minute. Just doing a finishing pass right now, but it sounded pretty good on the main part of the contour as well. Specs were about 1/8 inch depth of cut per pass, 4-degree ramp, 54 IPM on the ramp, and then 72 IPM once it got down to the level. Went pretty good. Nothing's really sounded weird. I was a little bit scared because it was like tearing through that stuff pretty fast compared to the other day, but it all worked out pretty well. So, yeah, there you go. So, let's go over the second one now. So, I'm going to go ahead and watch this, and I'll take another video as soon as this one finishes here. And it's cutting out the last piece right now. And it's doing a pretty good job. At first, you could see some chips getting clogged up in there. And I thought, well, maybe the air cooler's not working, maybe some chips are chip welding there. But I was wrong. There was no chip welding. They're just kind of loose in the slot. So it does a fine job just recutting them on its second pass. And that's when it cuts through there. And yeah, you can hear it quiet down because it's going to do the finishing pass now. And I've just done like a 3/1000 inch step over for the finishing pass. Doesn't need to be too much of a finishing pass. Really, the point of this mostly is to clear out the extra chips and give itself a better surface finish for the spring pass. But yeah, it's doing a pretty good job so far. And there it is, all finished. So I'm going to go ahead and unscrew all of those, and I'll be back soon. Oh, and by the way, I've been using these Everbuilt flathead brass wood screws. They've done a great job. Bought a 100 pack for like $7 at Home Depot, but I highly recommend them because this way, if your tool crashes, it's not the end of the world. You can just, it'll just hit the screw, shave off some brass, no big deal. They also are tough enough that you can reuse them for multiple jobs. Although I've used about, I don't know, like 40 or 50 in this job here because I've got so many different parts in that sheet. Not a big deal. I can just reuse them for the next job. Alright, so I took the pieces off the router and just peeled off the little covering and all that. And the results are pretty good, I must say. Very crisp edges there. A little bit rough on the surface finish. I think next time I'll do a slower surface finish pass. I'm also pretty sure this is acrylic, not polycarb. It's definitely not as flexible as polycarb. It's hard to tell on the larger sheets, but on the small pieces, it's pretty noticeable this is not polycarb. That's okay. Still cut just fine. I'm pretty confident. Polycarb seems easier to cut to me, so I'm pretty sure that these same feeds and speeds were fine for polycarb. So when I get my hands on some, I'll give it a shot there. You can kind of see on camera that these cut lines here are not that smooth. Smooth enough, but I mean, cutting any kind of plastic, you do have to be careful to get a good surface finish because it vibrates so easily. But apart from that, very good dimensional accuracy. I have slots in this base plate here. And these just fit. Let's see if I can get that. The light fixture there. These tabs just fit perfectly into those slots, and I cannot do this. There we go. Yeah, these tabs just fit perfectly into these slots. I have to tap a couple of these in just with my palm to get them to go in. That's how precise they were. I'm pretty sure my slots did end up about 1/1000 of an inch undersized or so, and my material thickness would have been a little bit higher than I imagined. Totally fine. Wasn't a problem because it is plastic after all. If I was working on like aluminum or something, I'd probably take a micrometer to it before cutting, but in this case I just kind of assumed it was like 0.2 thick or something. And I mean, it worked out. Things all go together pretty well. I did, however, screw up the design because you can see here, there's that tab pattern there for the front and back, and this is like a little tool holder thing I'm trying to make here. And on the front and back, I decided to have this tab pattern, and you can see that these don't match. This middle tab here, this cutout has to be a lot wider. So I think what I'm going to do for this is I'm just going to take this right here, and I'll just cut it off with a hacksaw or Dremel or something. Just get rid of that, and then just push this on and get some acrylic glue. That's probably work fine for this. But, you know, as a test of the router's capabilities and feeds and speeds on plastic, I'm pretty happy with this. Worked out great. End mill felt perfectly sharp after the cut, and really no real complaints here. Dimensional accuracy was good. I tested with some pins and calipers. Everything was within a couple thousandths of what it was supposed to be. Makes sense. But for the most part, it was good to within about 1/1000th of an inch, which I'm very happy about. Now, next time, I'm pretty confident this thing's going to handle aluminum. My new enclosure there should definitely be able to handle some aluminum chips flying around there. So as soon as I put my power strip somewhere that's not directly next to the giant mountain of chips that gets made with this thing, I'll go ahead and surface the wasteboard, which I haven't actually done yet. I've just been cutting on it dry, and cut some aluminum. And I'll probably do that, if not tomorrow, sometime next week. So I'll see you later. Oh, and by the way, I forgot to mention, I've got my mist coolant thing set up here. I haven't actually got any cool mist from the shop, so I just kind of tied up the little airline there for the water. But the air works totally fine. I bought this little kit off Harbor Freight. Comes with this cool little spirally cable stuff that goes down to the compressor over the enclosure. It's got a quick release fitting on it, so I can, you know, change it out if I need to. And I've kind of jury-rigged this thing where I take one of these guns here, and I can basically put this over it. Oops. I'm not very good at doing this while on camera. There you go. Yeah, like that. And that just stays on, and it does a good job of getting some airflow in there. So pretty effective. Pretty happy with that. But yeah, that's pretty much what I did. And I also found out that the spindle speeds I've only limited to 3 different speeds, not a 0 to 10 volt analog, as these spindles can actually, the VFD can actually accept. So I've decided that I'm going to have 1,000 RPM, 18,000 RPM, and 24,000 RPM. 1,000 RPM for edge finding and that sort of thing, and 18K and 24K for actual cutting. If I need to go lower than 18K or lower than 24K, I'll go ahead and I can change it on the VFD directly. That's not too hard. Alright, and I'll see you later.